So far, we've learned how to solve quadratic equations through the square root method and through completing the square. In Chapter 10.3, we're going to learn all about how to use the quadratic formula. I've written the quadratic formula up there in the upper right-hand corner, and we'll talk more about that. But if you want to see how they developed it, they did it by completing the square, and they show that on page 710. So if you look at 710, you'll see how they developed it, and it ends up that the quadratic formula x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. In using the quadratic formula, what you need to be careful about is the positive and negative signs. What we're going to do is problem number 2, and I'm going to do it two different ways. If you notice in problem number 2, I am able to factor x squared minus 9x plus 14. The question is, what two numbers when multiplied together give you 14 and when combined give you 9 or negative 9? And those happen to be x minus 7 times x minus 2 equals 0. And in fact, this is the quickest and easiest way to solve quadratic formulas, or quadratic equation, I should say, if you're able to factor the trinomial. Because then you do x minus 7 equals 0 and x equals 7, or x minus 2 equals 0 and x equals 2. And if we went back and substituted 7 into that, we would be able to come up with 0 equals 0, or if we use 2, because 2 squared happens to be 4, minus 9 times 2, 4 minus 9, 18 equals negative 14, and then negative 14, positive 14, it comes out to be 0. So our answers now were 7 and 2. Now, we've solved this by factoring that trinomial. Now we want to solve this using the quadratic formula. Using the quadratic formula where we put in x equals minus, and what is b? Well, b happens to be not just 9 but negative 9. So what we put in is minus a negative 9 plus or minus the square root of b squared, which is minus 9 squared, minus 4 times a, and a in this particular case, because there's nothing in front of the x squared, that turns out to be 1, times c, which is 14. This all is over 2 times a again, which is 1. All right. Now you can see this is going to be more extensive and more complex than if we could factor it. So it's not the approach I would recommend using if you can factor that trinomial. But what happens here is minus a negative 9 becomes just 9, plus or minus the square root of negative 9 squared happens to be 81, minus 4 times 1 is 4, times 14 happens to be then 56. That's all over 2 times 1. That's x equals 9 plus or minus the square root of 25 all over 2 times 1. Then x is equal to 9 plus or minus 5 all over 2. If that is the case, and I took 9 plus 5 over 2, I would get 14 over 2, or 7. If I took 9 minus 5 over 2, that would be 4 over 2, and that would be 2. So those two answers, 7 and 2, happen to be the two answers we got before. And when solving these, the expectation is that you will get two answers. Some rare cases you only get one answer, but that's because that trinomial it's a special square, like x squared plus 4x plus 4 is x plus 2, the quantity squared. And then you would only have one answer, which would be -2. But now let's go ahead and take a look at a problem that has an a term to it. In other words, let's take a look at problem number 8 that's still on page 717. All right. Problem number 8 on 717 is 4x squared plus 5x equals 6. What we have to do first is we have to set everything equal to 0. So I have to subtract 6 from both sides. And I get 4x squared plus 5x minus 6 is equal to 0. Now I can see if I can factor that and all that kind of stuff. But let's go ahead and plug that into our quadratic equation. X equals minus, and this time it's just a 5, plus or minus the square root of 5 squared minus 4 times a, which is 4, times c, which is -6. That's all over 2 times 4. This now becomes x minus 5 plus or minus the square root of 25. A minus 4 times a 4 gives me a negative 16. And a negative 16 and then times 6 should be a positive 96. And that's all over 2 times 4. Now x equals minus 5 plus or minus the square root of 121 all over 8. Well, it so happens that 121 is one of our perfect squares that we studied before. So this now becomes minus 5 plus or minus 11 over 8. So if we did minus 5 plus 11 over 8, we would have 6 over 8, which is equal to 3/4. Scrolling down just a little bit here, if we happen to take minus 5 minus 11 over 8, we would get minus 16 over 8, and that becomes -2. So our answers happen to be -2 and 3/4. Now let's take a look at number 14. And the reason I'm choosing number 14 is because in our answer, one of those, if not both, will be a radical. And that being the case, you will find that some of your answers will not come out even. That's the reason I wanted to choose number 14. In number 14, what we had was, this is 14, x squared minus 4x plus 2 equals 0. The numbers aren't that large in here, and it's in the right order. So what we're going to go ahead and do is plug that into our quadratic equation. Minus a -4 plus or minus that -4 squared minus 4 times 1 times 2. And that's all over 2 times 1. X then equals 4 plus or minus the square root of 16 minus 8. Okay? And that's all over 2. Now what we get is x equals 4 plus or minus the square root of 8 over 2. And you could leave it in that form, but what we notice is that we got the square root of 8, and that's the same thing as saying the square root of 4 times the square root of 2. And that square root of 4 happens to be a perfect square, so that's 2 times the square root of 2. So if we rewrite that, we'll have 4 plus or minus 2 times the square root of 2 all over 2. And now, because both 4 and 2 are divisible by 2, I can go ahead and 2 goes into 4 2 times, and 2 goes into 2 1 time. And we don't have to write that 1, so we just write it like this. 2 plus or minus the square root of 2. All right, looking at one more, I'm not going to do this entire problem, but what I am going to do is take a look at the problem because it is a lot like the first problem we did. You can use any approach that you want using but looking at number 32, where it says x squared plus 4x equals 21. Now, it says even in the instructions, solve each quadratic equation. You could then transfer the 21 over, which then sets it up as x squared plus 4x minus 21 is equal to 0. Now the question is, what two numbers when multiplied together give me 21? And the difference is 4, and those two numbers happen to be 7 and 3. So what we get is x plus 7 times x minus 3 equals 0. If it's x plus 7 equals 0, then x will equal negative 7. If it's x minus 3 equals 0, then x will equal 3. So that even though this section is about using quadratic equations, if you're able to factor some of those, that's the way to go. And that's why I showed you that. If you wanted to do that problem using the quadratic equation, you could, and you should get the same answers. Now what I want to do is take a look at problem number 50. In problem number 50, what they have is a story problem involving geometry. And what's important is, how do we set this up? We'll use the quadratic formula for the solution. I'm not going to get there because you now know how to use that. But it says the hypotenuse of a right triangle. Okay, so I'm going to draw myself a right triangle. And the hypotenuse is right here. That's side C. The hypotenuse of the right triangle is 6 centimeters longer than the shorter leg. So if I let x equal the shorter leg, then that hypotenuse should equal x plus 6. And now I have the shorter leg, that's equal to x. All I have left is the longer leg. And the relationship between the longer and the shorter leg is the length of the shorter leg is 2 centimeters less than that of the longer leg. Oh, wait a minute. The shorter leg is 2 centimeters less than the longer leg, but I let x equal the shorter leg. Well, if we reverse our thinking, then that longer leg should be x plus 2. That makes it longer than the shorter leg, and now we have everything. If you recall, in solving for the hypotenuse of in the Pythagorean theorem, we had c squared equals a squared plus b squared. Now, in this particular case, we're not going to solve c equals the square root of. And that because what we want is lots of squares. So I take our hypotenuse, and that's x plus 6, that quantity squared, equals a squared, and we'll make that our shorter leg, x squared, plus our longer leg is x plus 2 quantity squared. When we square everything, what we'll get is x squared plus 12x plus 36 equals x squared plus x squared plus 4x plus 4. Now what we have is x squared plus 12x plus 36 equals 2x squared plus 4x plus 4. And since the larger value of the x squared term is over here on the right, what we're going to do to set everything equal to 0 is just subtract everything out. So I'm going to subtract x squared, I'm going to subtract 12x, and I'm going to subtract 36. So if I do that on the left, I have to do that on the right. Minus x squared minus 12x minus 36. Now what I get is on the left I have 0, and on the right I have x squared minus 8x minus 32. And if I knew of two factors when multiplied together gave me 32, the difference of which was 8, I'd be in like Flynn, but there isn't any such thing. So that means to solve this problem, we have to use the quadratic formula. So that takes care of problem number 50 on 718. I want to take a quick look at problem number 56 on 719. Problem number 56 is one of those formulas that they love to use having to do with height, velocity, and all that kind of thing. It says in number 56 that if a ball is thrown vertically upward from a height of 5 feet, from a height of 5 feet, with an initial velocity of 96 feet per minute squared, its height h after t is given by h equals negative 16 t squared plus 96 t plus 5. All right, we don't know what the time is, but we do know the height. It says thrown up from a height of 5 feet. Okay, so we know the height, and we say that's 5 equals negative 16 t squared plus 96 t plus 5. So to get 0 on the left side, I have to subtract 5 from both sides, and now what I get is negative 0 equals negative 16 t squared plus 96 t. Now, I can still solve that using the quadratic equation, but if I want to factor something out to make it a little simpler, if I factor out negative 16, what I get is t squared minus 6t. Now using just 1 for the a and negative 6 for the b, the solution to this then becomes much easier. So when you're doing a problem like that, make it as simple as possible by factoring out a common term when you can.